Hello YouTube, watch this. No, no, no. I'm alright. Watch this tutorial. Waawuawuaa! I am back because I wanted to provide some content for my favorite viewers. That's you. Many of you expressed that I should make a tutorial on Counter-Strike Condition Zero, but also make the videos longer. So here you go, 1 hour plus Aimbot course, start to finish. We will begin with nothing, and at the end you will have a beautiful aimbot menu that aims on the closest enemy at the press of a hotkey. You just need to press the shoot button to kill them. The coding structure can be transferred to other games, so completing this course will set you up for greater applications in more games. Please let me know if you guys like this sort of longer and less edited content, or if I should continue with the shorter time frames. Also, write down any other suggestions you want me to explore, like an ESP, bunnyhop, you name it. Now, I know some of you, including me, learn better by having the complete source code available during the tutorial. So if you want to download it, then join the Patreon membership. It's only $5 and you support the channel as well. But always remember that you should never use cheats or any external programs for unfair advantages. You will get banned. We will specifically go through how to set up a safe environment in this tutorial to avoid these things, so make sure you follow it. Now enjoy this video. Alright, so let's take a look at what you will have at the end of this tutorial. So here are some enemies, we have our player, our weapon, and we will now start our final Aimbot project. So click on the play button in Visual Studio and you will have a little window. You can customize this however you want. This is just a generic version. It has a checkbox for the aimbot. If you disable it, it will not work. But if you enable it, you can see a dynamic text depending on if the aimbot is aiming or not. So if we now hold the aimbot key, it's the mouse 5 button, you can change it to whatever you want. But if I hold it, it will now aim on the closest enemy. We can now just shoot. I wish you all the best of luck following this tutorial, and I'll see you in a little bit. Alright, before we jump into the actual aimbot making, let's get a better overview of what we will do. So, the tutorial is divided into two main parts. The first one will be to get the offsets, and what we mean by getting the offsets is that we will use Cheat Engine to find memory locations for our player in the game, our position, our health, our team value, and then the other entities, for example our teammates, the enemies, and the same information about them, position, etc. The last thing we will find is the view angles, and that means the X and Y, the yaw and pitch for our character, so we can force our character to then move on the other entities. That's the offsets part. After that, we will take these offsets and bring them into part 2, program the aimbot. So we will take this information and then code our program to efficiently read this information, then force the angles, so the view angles, to aim on the other entities, plus some more stuff like rendering the menu and the hotkeys and stuff like that. So let's get into this tutorial now. Welcome to finding the offsets part of the tutorial or course. So in Counter-Strike Condition Zero, we will need to find some memory addresses that hold the information that we need. For example, our player, the enemies, and finally our view angles, which means the pitch and yaw for where we aim. That's the core information that we need. So in Steam, before you do anything, right click on the game, Counter-Strike Condition Zero, go into the properties, and in the launch options, add -insecure. This is incredibly important because otherwise you will be banned if you open sheets without this command. Secure servers will ban you if you don't have this command in use. Perfect. After that, we can start the game. And I have set the game into windowed mode. I recommend you do the same. In the game, we will click on new multiplayer game. This is not official servers. It's just a local multiplayer game. Don't worry about it. Let's disable Steam networking. I don't think it does any difference. And let's pick Dust2 and include some bots. We will pick the number 4, include bots, and there will be an easy. So let's click on start after that. Now you can see that there is no Secure logo in the loading screen, which is good because we don't want that. Let's join the T side, and after that you will click on the button below the ESC key. That will open the console and you will see that we have Secure mode disabled. If you don't get this command, redo the process until you have this message in the console. We will write svsheets1, then bot stop 1. This will freeze the bots and not allow them to do their shenanigans. They will just stand in their place. Now, let's open some sticky notes. We will use this to note down all of the memory addresses and logic that we find. I don't care about Java. There we go. Now, because we have the game in -insecure mode, we can open Sheet Engine. So I have a tutorial on installing Sheet Engine without bloatware and with the debugger that we will use in this tutorial. So make sure that you have followed that video before this one. Alright, let's attach it to the game. There we go, Condition Zero, that's our game. And we can begin finding our offsets. So the first offsets that we will find is the crosshair or the view angles that we call them. So let's write down view angles, then equals, and here we will place our address. So let's find it. Now if you remember from my previous tutorial on the silent aim video, we found the view angles by moving our crosshair up and down, because in this gold source engine, or at least in this game, the view angles, the pitch is negative towards the upper part and positive when you go down. So what we can do is we will search for positive 89 at the bottom, a float value. We will write 89. It's not 90 degrees perfectly, it's 89. Search for 89. Go upwards and search for decreased value. So decreased value. Go up, decreased value, decreased value. and continue like that. So we have 83 addresses, but I don't think there will be much of a hassle going through them. So let's pick out the green addresses with the hw.dll. This is because the hw or module seems to be the same for all of the gold source game, or at least the ones that I've tried. So let's pick these ones, put them in or down, and we will freeze them to see if our crosshair stays in place. So it does, and we have found our pitch. Now we don't know which one of these it is, so let's remove half of them and look if our crosshair can move. So because we have frozen these ones and we can move the crosshair, we know that it's not any of these. So let's remove them from the list. To select many and freeze them, I just pick one and then shift, select the next one and the spacebar to freeze. So we check the next ones. We can see that our crosshair is in motion. That means it's not one of these. Let's pick up these. We can, or our crosshair is frozen, which means that it's one of the frozen ones. We delete the others, pick one, and we can move the crosshair, which means that this first address has to be our view angles. Let's confirm it, and it is, because it's frozen on the y-axis. Perfect, so I have our view angles, and with the view angles, or you would think that because it's probably a vector, the next value has to be the z value because xyz. But for some reason, it's the y value before the x value. So if we add 4 in hex, just a float value, we go to the next float value, we can see that it has a value of 88. So if we save that and freeze, we can see that we have the x-axis or the yaw. So we have found both x and y, and we will use that information for later. So let's remove that, click OK, and I forgot to unfreeze it. There we go. And we will write down our first memory address. Wasn't that easy? Perfect. Now, the next address will be our local player. So our player's address. This will be used because we need to find out our position and hopefully our team, because we want to differentiate between enemies and teammates. So we will write down local player equals and then find our local player. So like in previous tutorials, to find the health, we will search for a float value. So let's search for 100 float. 100. Take some damage. 96. $92. All right, let's do one more. $88, and it doesn't seem to change in amount of addresses. So let's begin to try these ones out. Let's pick out the white addresses, the dynamic ones, because we will be looking for a dynamic object, our local player. We will not pick one of these green ones because they're static. It doesn't fit our object model or whatever other reason. So let's change them to a value. Let's pick half of them, change them to 50. Nothing changed, we still have 88 health. Let's delete these. Let's change another health. 40. Still 88. Change these to 30. No change. Delete. Let's pick the bottom ones. Change these to 40. And we have 40 health, so it can't be any one of these. Delete them. We change these to 70. No change, which means it has to be one of these four. Let's change the bottom two to 80. And our health changed, which means it's one of these bottom two. Let's change this value to 100. And we have 100 health, or 100 health. So it was the very last one. Let's remove the one above and local player health, we call it. So we have the health of our character. Now we will need to trace backwards to find our local player. To make things easier, we will use in the settings, we will use the debugger VEH debugger and right click, find out what writes to this address, take some damage and look at the offset. So we took some damage and we can see that there was one instruction on this address that moved a value, or moved this register value into EAX plus 160 with the pointer reference. The information we will take out from this extract is that the offset was 160. So we don't know the local player address yet, but we know that the health equals 160. So we didn't even need to get to the local player to get to the health offset. And we can use this offset to perform a pointer scan. So we close this, then right click, pointer scan for this address. Let's pick the max level of offsets to 4 at the beginning, and then check the option pointers must end with specific offsets, and pick our offset, which was 160. That's our health. So that will filter out a lot of addresses which just point to this value without being correct. So let's click OK. And we pick a name for it. Let's call it player health. Amazing name. Then we hit save and wait a bit for it to go through. It's an older game, so it's faster. And we only have 225 results. So one of these will probably be our local player base and point to our local player, but we will need to reset the game. So we hit the X, open the game again. Remember, we have it in dash insecure mode. Otherwise, do not open the game with Cheat Engine open. And pick the same map. On the T side, we write SP sheets 1, then bot stop 1, and they have stopped. Now we can attach it to the game again. Condition 0. We keep our address list, code list, because we have our view angles and local player. The local player health doesn't matter now, but we have our view angles, so we will keep the addresses. Then, because we know our health is 100, we can perform a rescan of these pointers, rescan memory, then use value to find. We pick the float data type and write 100. So hit OK, and we add a 2 at the end of our pointer scan, click save. Now we have only one result that could be good or bad, and it leads to 100 health. So let's hope that this is our local player base, or maybe the entity list base. We don't know that yet, so we will have to confirm things. We double click it, and here we have our pointer. Let's remove our local player health address because we have, or that one is not needed anymore. And we will investigate this pointer. So we can see that 160, our health offset at the end, then some sort of 4 offset, and a 7C offset. So we don't know much about these offsets. So let's remove them, remove offset, and take a closer look at this base. So we select the address, then Ctrl B, Ctrl D, and Ctrl N, and hit OK with the guest field types enabled. Here we can see the pointer from its beginning. So our pointer, close that one down. The first offset was 7C, so let's go one step into the pointer and take a look at 7C. Here we can see that it says pointer to instance of C-base player. That means that this is probably our player address. C-base player sounds promising. So it is not the 4 offset that leads to the player base, but instead the 7C. So what we can use with this, or write down with this information, is that this address, which is the base, plus 7C is our local player. Remember, we had our base, then offset 7C leads to the local player. Now let's go into this pointer and look at the other offsets. So we go one step into that, and here is our 4 offset, like our pointer. 4 offset. Here we can see some sort of vector. I think that's a position. Yeah, it's some sort of position vector that we could probably use. But let's go further and find our 160 offset to confirm that our health is there. Here you can see some 2 values. This looks like something. This 2. But at 160, a float, we can see that it says 100. We can even change this value, like our value before. So that's probably our local player, C-base player, and we have confirmed what we have been looking for. If we go back to our base, one step into it, and scroll down, we can potentially find some other entities if we're lucky, because here at 7C there was a pointer to an instance of C-base player. Let's look if there's any pointers to some other sort of entities. There is a pointer, but let's keep scrolling. More pointers, and at 3A0 we can see that it says pointer to instance of CCS bot. So we have found some other entity at our, what we thought was the local player base. We might have found an entity list instead. Let's keep scrolling to see if there's any other entities. CCS bot, we have found another CS bot. So I think this is an entity list instead of just a local player base. That means we can write down entity list equals, and we have the same address, but we need to calculate the step between them. So from this, the second entity, we have the 6C4 value. Let's pick out the calculator, go into the programmer. In the hex tab, we will write the offset 6C4 and then subtract the first entity, or the first other entity, not us, CCSbot, which was 3A0, 3A0. Now we have 324 as the difference in between them. So remember that our local player was at the offset 7C, which is less than this value. So we will have to also add that into calculation. But let's look at the next entity to see if our steps were correct. So if our step should be or is correct, we should be able to add 6C4, add 324, and at 9E8 we should find another bot. So let's scroll down. 9E8, pointer to instance of CCSbot. So we have found our step in between the bots, but we will have to also begin at the C base player. So at 7C, the next entity was 3A0. Let's take 3A0, subtract 7C. If we get our 324, still the same step, but we will have to take the 7C plus, then just to remember, we will write I times 324. So that means the iteration. This is our logic. We will take the base, then the offset will be 7C plus whatever entity number we go through the list. Perfect. Now that we have our other entities, let's look at them to see if they have the same structure. So at the offset 4 and 160, they should have their health. Perfect. Let's change it to 50. Is that a teammate or an enemy? 100 health. So it's an enemy, which is perfect for our situation. In fact, you can also make it way easier. You can disconnect, create a new game with just one enemy. That should, or pick 2 CPU players. I wonder if they both join the enemy team. Yeah, they both joined the enemy team. So we only have enemies now, and we should be able to differentiate if the entity is a teammate or an enemy. So if we, let's close it down, open it up again. Here is our C-base player. Now, what we will do is, we will take the address, double click, copy that, add that down, a local player, then take the address of an enemy, CSbot, take the address, copy, add address manually, write down enemy, and now you will select the local player, Ctrl B, Ctrl D, Ctrl N, then right click on the, or never mind, just click on the file and add extra address. It will duplicate. Then you copy the enemy base, paste it in the other address, and now the values that are different will be highlighted in red. So this points to something different, which is correct, and we can select the values that we think might be the team number. So often a team number will be the value 1 or 2 or perhaps even 0. So let's begin by picking out the 1 and 2s that are highlighted in red and check by switching teams if they are team values. Let's skip the 3 at the moment, make things simpler. So we have 4 offsets that are either 2 or 1 and are highlighted in red. So you can hold Control to select more. Let's change teams and look at the values. So we join the city side. Now you can see that it changed from 1 to a 0. Even here, this value changed from 1, or I think we have to join the team. Let's kill the bots so the values realize. Okay, so the 1C0 and 1D0 has the value of 0. The 1A0 didn't change from 2, which leaves the 1C8. That is the only one that changed from 1 to a 2. Now, it could be one of the zeros, it could be this other value that was a 3, but I think the most logical one is the value that changed from a 1 to a 2. Let's write down the 1C8 as the team, and finally we will pick out a value to be our position. So in the C-base player, let's just scroll down until we find 3 floats that have position values. Here we have 2 floats, that doesn't matter, it looks like some sort of view angles. We scroll down, here are 3 float values that are different, which is good. And if we move, we can see that the values change. Amazing. So this would probably work as a position offset, but from experience, I have tried these out. Oh, never mind, it changes without me changing, so this can't be our position values. Let's go to the next 3 floats. Scroll, scroll, scroll. Nothing. They change, so we don't care about them. Scroll, knife. Is that the... Yeah, so that's the name of the weapon that we have. That could be useful. I think these are some position values, the 195, 247 and 2300. Never mind, it doesn't change. Let's Oh, I think the values are wrong. So that's a string that's supposed to be a float value. You can see that the 7DC and 7E0 resembled float values, and the last one just what was in the wrong. So you can see that these values change only when our position changes. And we can also confirm that the last value of the 3 values have the same as one of the others because it's green and we're comparing an entity. So we're on the same z-axis, which is good, and we have 2 other position values. Let's write down this 7dz as our position. Position. Amazing. We have finally found all of our offsets that we need. Now we can begin to code our aimbot. Okay, so we have our beautiful offsets. Let's add a parenthesis there, so we remember things, and we're ready to code our aimbot. Now, here I have Microsoft Visual Studio Community Edition version 22. So I have a tutorial on downloading and installing Visual Studio with C# programming. So make sure that you have everything set up. Let's create a new console app. We will call it Aimbot tutorial or whatever you want to name it. Click on next. Then for the framework, we will pick the .NET 8 framework for this tutorial. Then create. Not now, and here we have some paste text. We go into the project, then properties. Here we will go into the build and set the platform target to 86. This means it's 32-bit. Perfect. We close that one down, and we will now install some packages that we will utilize in this project. So manage NuGet packages. Then in the browse tab, we write Swedz32. That's my memory library. We click on install, apply, accept, and then we install the clickable transparent overlay. But remember to pick the 9.1.0 version. Otherwise you will have issues with the overlay not displaying fully on the screen and other stuff if you pick a newer version, at least for the .NET 8 framework, or that's what I believe. So we install, and we're ready to go. So let's close that one down, and in our main project folder, we will create some classes that we will use. So right click on the Aimbot tutorial, then add new item. Here it's a new class that we will create. It's called entity. So this is the ground object, the core object of our program, which will hold the information of the players. So the health, the address, the position, and the information that we need to make the aimbot. So in the entity, we will set it to public, and we will have a public int pointer address. This one isn't really needed, but it makes it way simpler to actually, let's remove it because it's not it's not needed. But we will have a public vector free. We'll use system.numerics, and we'll call it position, and with a get set, so a getter and a setter. This is a method, and that's why we have the capital P for correct naming conventions. Then we will have a public float health. That's our health. We will store it as a float, just like in Shitanian. Then we have the public and then an integer t to store it as a whole number, either 1 or 2, to differentiate if it's a teammate or an enemy. Finally, we have the value of the distance. So this will just be a calculation to see how far away the enemy is. And then we pick the enemy who is the closest to aim on. Perfect. Let's minimize the entity for a bit and then add some offsets. Why not? So let's right click, add, then new item, just like before. We call this one offsets instead, then add. And in this new class offsets, we will have it also set to public, then static class offset. So the reason for the static part is because we don't want to instantiate this class, we just want to pick out the values in the offsets class. So here we can just write public static int, then our addresses, so the view angles was our first one. We pick out our nodes again, copy the value, 0x, then paste. You need to add the 0x to make it a hexadecimal number. And that's how we store the addresses. Let's add a comment to have our hw.dll, just so that we know which one is which. Public static, then our other entity or addresses. So now the local player and entity list, they have the same base, so we don't really need to create a local player address, we just need to add the entity list. Let's pick out the address, and we're done with the HW module addresses. Now we will add some entity specific offsets, which is the health, team, and position. Never mind. Let's just write them out. Public static int position, which was 7 DC. Public static int health, which was 160, we know that. And finally the team was 1Z8. So we write public static int team equals 1Z8. Perfect. You can add more offsets here when you want to make your sheet better or your aimbot better, but these are our offsets for this tutorial. So let's continue and minimize that class. We actually have one more class that we will want to create before starting our program class, which is the our menu. So we will render our menu in a different class. So we add a new item, call this one renderer. In our renderer class, again it's a public class renderer, and we will use or be using clickable transparent overlay and imgui net. In the renderer class, we will inherit the overlay class, and then because we inherit the overlay, we will have to implement the abstract member overlay.render. So let's just write protected override void render to satisfy Visual Studio, and no more error. So here is the part where we render our menu, and here we can add some variables to store information and so on. Public bool, so this will be the checkbox values. Enable aimbot, that's just a switch, either aim or not aim. Then we have the public bool of enable aiming on enemy. So this boolean is the text that you saw in the showcase. So if it aims or not aims. It's a green text. So it's different from the enable aimbot, but it's a boolean on the least. Now in the render function, we will write imgui to create a new window, begin, then just write my aimbot, my awesome, my aimbot. And then a checkbox with the aimbot feature, then refer to our boolean, and that's it. So now there's a checkbox and it enables or disables our aimbot. Now you could be done here, but we want to have the text that says either aiming or not aiming. So set text, and here we perform a simple if. Check if aiming or enable aimbot and enable aiming on enemy. We will have a imgui.text colored and then new vector 4. Let's add a using system.numerics. Perfect. New vector 4, and with this vector 4, it's the color, so RGBE or RGBA values, which means it's the red. We don't want red, we want green, and then we don't want any blue, and we want the alpha to be 1, so it's so we can see it. Then we have the text. We'll just say aimbot aiming. Perfect. If it's not the case that we're enabled, we will just check that if enable aimbot, and then just write the same thing but with red instead, and aimbot idle, because we're not aiming on the enemy. Let's add imgui.end, and our menu is complete. Perfect. We can now begin our main program. Wow! That took a while just to create the things needed. Let's remove that text and begin by writing using Swedz and initialize my memory library. So the Swedz library just wants you to create a new instance of the Swedz class and then provide the process name. So the process name, you can see it in Sheet Onion, is hl.exe. I'll fly for whatever. So we write the name of the process without the exe. Not like this, but it's not like that. Let's get the module base, because we will be using the base address of this hw.dll. So get module base, which will be an int pointer. That's how we use addresses and so on in the Swedz module or Swedz class, which will be equal to the swed.get module base, then the name of the module hw.dll. So here we write the .dll. Let's initialize the renderer by creating a new instance of it. Then have a thread that runs and does the things that it needs. So new thread start, renderer.start.wait, and there we go. So instead of having things run in one thread, we will have a separate one for the renderer to just simplify things. Good. We will now initialize our entities, which is as simple as creating new classes. So one entity will be our local player, and the other entities will be a list of entities. So we have the entities, and the next step would be to add a hotkey for our aimbot. So the hotkey we can get from the internet. Here we have Google, and we will simply search for Microsoft Virtual Key Codes. This will bring out a table of hexadecimal values that we can write down. So here you see the description, left mouse button if you would want to use that. I wouldn't. I like to use the mouse 5 button, which is called X button 2 for some reason. Extra button, I suppose. But it has the hexadecimal value of 0x06. So we write hotkey and we write down our hotkey. So const int, and then let's call it hotkey underscore aim, and the value that we chose. You can pick whatever you want. This is just my favorite one. Let's add a console text to sort of indicate that's where we are opening the aimbot. This will not make a lot. It will not make a difference in efficiency or anything. It's just text. Let's write starting aimbot ... Perfect. Let's begin with our logic, so our actual aimbot loop. Aimbot loop. Here we will have an infinite loop, so while true, this will always run, and we will begin to read our local player and the entity list because they have the same address. So let's create a new variable called entity list. This will have the value of Swedz.readPointer with the HW module, then offsets dot entity list. It's that easy. Now we have the entity list. So we are here at the moment. Now we can go to the local player and we can go to the other entities. So let's have the local player address. Oh, it's actually needed the address in the entity. Let's go back to the entity and add the address part quickly. Public int pointer address. That's my bad. And now set the address to Swedz.readPointer with now the entity list as the base, and then the offset 0x7z. So that's how we got to the local player. We could add this into the offsets class. Maybe we should do that. Go into the offsets, then add a third part which is called list. Here we can be public static int initial entity, which is our local player. That was 7c, this value, and then the step we can call the next one. Step equals 0x200 324, and that's it. So I have our address. Now we will add our position because that's what we're interested in. And to do that, we have swed.read vec for vector, which is really handy because we can just have the local player dot address, then our offsets dot position. Remember, the position was the offset was of the local player base. Then we can add the team. Read int, it was a whole number, then again local player dot address and offsets.team. Perfect. So we have our information about the local player. Actually, I think I want to test these things. Let's add or use the offsets.initial entity instead there. Okay, so I open the game again in dash in secure mode, back secure mode disabled, and let's just go and add a breakpoint there. Click the run button, it's in debug mode. And we should now collect the information about the local player. You can see the little window starting Aimbot, and we have our local player. Amazing. So here we can see the address now that we got. We have the distance that is not calculated, the health we don't read, and the position is here, the team is 1. So we have gotten the information that we read. Let's continue. The next step will be to read the entities. So we will have a for loop, which is, let's pick 32 entities. I don't know how many players you can have. 32 is a good number though. And we will get the current entity, so the current iteration of entities, by having a int pointer, then current ent equals to swed.read pointer, and not the HW module, but the entity list, just like before. They had the same address, remember? And we will now calculate the current entity offset. So it had the 7C, or the initial entity, plus, and we added this little logic to our offsets list, I times 324. So let's just straight up write that. So we have the offsets dot initial entity, zoom out, plus the 7C plus I times, here is our I variable, so the current entity times offsets dot step. That's it. So this is the same as 7C. So we could write it like this. This is the absolute same, but as we had made variables for these, let's just use them. So we get the current entity. Let's check if the pointer leads somewhere. If current end does equal int pointer dot 0, we will just continue to the next entity. And if the entity has an address, or the pointer is not 0, we will read some attributes. So check attributes. So we will only read the attributes here that we need to filter out if the entity, or if it's an enemy and if it's alive. So that's the information we will examine. So let's get the health of the entity, and to do that we will have to first go, oh no, if you remember from the offsets, it actually was 4 before the 160. So we can't just read 160 here, sadly. We will have to create some sort of, let's call it health component, for lack of a better name, read pointer, then the current entity now, not the entity list, and the 0x4, which was the second offset. And we can finally get the health, which was a float health equals to Swedz.read float current, not current entity, but health component, and the offsets, capital O, offsets dot health. Perfect. So I have read the health now. We will have to also get the team number. So this is the part where we can confirm if our team variable was correct. So offsets.team, because it was off the base, and here we go. So let's do some simple checks by using the if and then team. Now let's just check the health at first. So if the health is greater than 1 and health is less than 101, so if he's alive, we will simply create a new entity and fill him with the attributes. So the address equals the current end, team equals the team, health equals the health that we read, the position equals Swedz.read_vec. This autocorrect is not really that good in Visual Studio. I need the AI one. You will understand. We can also read the distance, which is just a vector free command. So we take him from the local player and the entity's position, which is the Euclidean distance. Entities dot add entity. So we will check if he's alive, then add the entity to the entities list. So this list. Now at the end, we will clear the entities.clear to remove them at each loop. But let's actually add a breakpoint here to check the entities that we have. So we will hit the play button. And we should now, our local player is the same, but if we add the entities to the watch list, we should have the amount of players you have in the game. So I have 10 in total. I am one of them. But we should be able to see if our team variable is correct. So you can see here the health, the position, and the team finally. So what you can do is you can click the pin button and then minimize that. You should now see the variable or the value of that attribute, so we can compare the object. Team 1, team 2. So there's 1, 2, 3, 4, 5 team 1 and 1, 2, 3, 4, 5 in team 2, and they seem to have different values from one another. So I think that we have gotten the correct team value, but only time will tell, I suppose. Now that we have confirmed that we can read through the entity list, we will perform some more checks. So the health, we know that he's alive. Let's also add a check that the team does not equal our team. Now we only capture enemies. So if we add a breakpoint now, we can see that we only have 5 entities and they all have the other team value. Perfect. We only capture the enemies. Now the only thing left will be to order them by closest to furthest, then aim at them. So to order them from closest to furthest, we can simply set the value of entities to entities.ordered by not e.team but o dot distance, because it's from lower to higher, so the ones that's closest gets put in first, and that's it. It's pretty simple to use these innumerable lists. Now that we have the closest enemy, we want to aim at them, but we don't have any logic for aiming at the enemies, so let's add another class. New item, class, let's call it calculate. It will be a public static class. Just like before, we will not instantiate it. And in this calculate class, we will have the infamous, never mind, not the infamous, but we'll call it calculate angles. This will calculate the new view angles that are needed to aim at the enemy. So we will have 2 positions, vector 3 from, and then vector 3 to. So from and to, this is us and this is the enemy. 2 positions in 3D space. So let's have our float yaw and float pitch. Those are the variables, and we will begin by calculating the yaw. So the yaw for the x value is from 0, I think, and then goes to 180 and then minus 180. Let's attach sheet onion again. Remember, I have back secure mode disabled. Keep the list and inspect the view angles. So the view angles here, if we add 4 in X, we can see that when we move to the left, it goes positive 200, 300. So it goes up to 160 degrees, then resets. So it is probably aligned with the x-axis of 3D space, and we can simply, by using some, I think, 8th grade mathematics, calculate the angle for this x-axis. So if we bring out a 90-degree triangle, to calculate the degrees, the angles from 0 to our enemy, imagine that this is our enemy, this is us, and this is the angle we need. To calculate, we will simply have to use either sin cos or tan. I think tan is the simplest. We will use a tan, but we will have the x value and then the y value. We don't need a z value yet, or at least for the yaw. And so we take the inverse, or whatever it's called, a tan 2 of the opposite and the adjacent, so the x and the y, and we get our angle. So let's do that in actual programming or with our mathematics functions. So the yaw equals, then we cast it as a float. We have our view angles in float, and our math function actually returns in double. So we cast it as a float. A tan 2 to get the angle after getting the tan value. And you can see here that it returns I think it returns in radians. So just remember that. We will use the a tan 2 with the, oh, my bad, we need to calculate the delta values. Delta x. So the distance between our player and them, which will be that delta x equals to 2.x minus from.x delta y from dot x, because we have two different values or two different positions, and we grab these two, delta y and delta x. And now, because we have this a tan 2 return in radians, we would have to convert it into degrees, your 360 degrees, by multiplying it by 180 and dividing it by math.pi. So it isn't that hard. 2 degrees from radians. Perfect. So we have successfully now calculated the yaw. Now we need to calculate the pitch. Calculate pitch. All right. So for the pitch, we will need the delta z value, so the height value, and we will need to get the hypotenuse, or hypotenuse, I think it's how you pronounce it. And to do that, we will have to get the distance, math.square root, math.pow, delta x 2 to the power of 2, and math.pow delta 2. And we have the distance, which is the hypotenuse. And with the hypotenuse, because we need to create a line between our player and the enemy, we now have a new adjacent in our triangle. So the opposite will just be the delta z value. So interesting stuff. And we can simply calculate. I shouldn't use the word simply and so on. It's bad manners, but whatever. We calculate the pitch, and if you remember in game, let's take a look at the pitch value by subtracting 4 again. The value goes from 0 to minus 89 and positive 89 going downwards, but because it's inverted, we would have to create a minus value. So just add the minus and then math.a the same stuff as before. Take the a tan 2 now with our delta z value and our distance, which is the hypotenuse, multiplied by 180 divided by math.pi to get it to degrees, and we are done. So we didn't need to calculate any sort of other values, or I forgot what I wanted to point out, but let's just return the view angles, pitch, so X and Y, and we are done. Now we have our aiming function. Let's add a hotkey. To use our constant here, dll import user32.dll, and it will be the static external short get async key state with an integer of the virtual key. Perfect. So here we just put the constant. So if we are holding the get async key state, our hotkey aim, and it's less than 0, it's negative, and we have enabled our aimbot in the menu. This old thing, if it's enabled, we will also check that there is an entities that is important, greater than 0, and if all of these add up, we will set the text of the enable aiming on enemy to true, so that the text changes, and then set new or calculate the angles. Vector 2 equals, or not equals, but calculated angles equal to calculate angles with the two vectors, which will be the local player position and the entities. The first entity in the list position. Remember, we have checked that the entities list is greater than 0, so we just pick the first entity. And our new angles will be a new vector 3. So we create a completely new one. We will not just write with this. And because we have a new vector 3 here, we can set the y value before the x value. So calculate angles.y, and then calculate angles.x, and finally a 0 value, which correctly sets the view angle. So remember, our vector 3 has x, y, and z. We would have to reverse the values. Let's finally write over the angles. Swedz vec, and now our HW module. Let's take a look at the sticky notes, view angles. So the HW module, then this value, we have it in our offsets list. I can barely speak. View angles, our value, my bad. New angles, and if we didn't hold the hotkey or anything else, it will set the text to enable aiming on to false. So it resets the text. Perfect. We're actually done now with the aimbot. Let's test it out. Alright, so I realized the error, and that was because I trusted the autocorrect from Visual Studio and it didn't change on the delta y. to Y. Somehow the autocorrect is really bad, but this is the correct calculation. Delta y should be 2.y, so, or minus from .y. After that, we can also change from 32 to maybe 12, because you usually have 10 entities in the game. 32 entities isn't needed. Alright, let's try it out. So if we hit the play button, you should have your window starting Aimbot, then an in-GUI window with your Aimbot checkbox that you can enable or disable, and the Aimbot should say idle once you, or when you don't hold the hotkey. Let's minimize these things and try it out. So here I have some enemies. If I hold the Aimbot hotkey whilst 5, it says aiming, and we can see that I aim on the closest enemy. Headshot.
3 to go.
If I hold the Aimbot hotkey, it aims on the enemies. So this Aimbot does not have a head position value. You can see that it aims on the shoulder. You could probably make it better by finding some head positions, but it's an Aimbot nonetheless. There seems to be something odd. But thank you guys for watching.